Do you remember what you were doing on December 25th, 2021? That's a day I will never forget. Now, if you're a bit like me, you might have been celebrating Christmas Day. That would be reasonable. But if you're a lot like me and you love space, then you were celebrating something else.
And we have engine start. And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
The best Christmas present that astronomers could ask for. That was the successful launch and deployment of the James Webb Space Telescope. In fact, it was so exciting for me, I remember taking a break from a very nice Christmas lunch to share some insight about that on the news on Christmas Day. Well, now it's nearly 3 years since that happened, and the James Webb Space Telescope has been out there in space, making incredible discoveries and taking extraordinary images, unprecedented images that far exceed expectations. And I want to share some of them with you today. My name is Tom Kerss. I'm an astronomer, and I'm also the author of a new Collins astronomy book, Unknown Universe. So launching just in time for the 3rd anniversary of Webb's time in space. This beautiful book contains over 120 extraordinary images from the telescope. And those images include some surprises, maybe some that you've never seen before. And of course, as an astronomer, it's my job to decipher those images for you. So I've provided my own insight for you to read as you go through them. To celebrate Collins Astronomy Week, I'm going to share 5 of my favorite images from Unknown Universe, 5 of my favorite images from the Webb mission so far. But before we jump into the images, I want to talk to you a little bit about how these images are made. The James Webb Space Telescope is probably larger than you think it is. In fact, its sun shield, which is famous for protecting it from the heat and light of the sun, is about the size of a tennis court, and its mirror is 6.5 meters wide. You may have seen that the mirror is made up of these hexagonal segments, and there are 18 of them in total. So by just comparing them to the size of an engineer here, that gives you some idea of how large the main mirror must be. That huge mirror is intercepting light. Not the light that we see with our eyes, however, not the optical light as astronomers call it, but rather infrared light. Now, some of the infrared part of the spectrum is what we feel as heat, but Webb sees all manner of infrared wavelengths, and that's important for scientific reasons. That infrared light needs somewhere to go, so the mirror assembly focuses the light and brings it to focus at what we call a focal plane, and at the focal plane there are multiple instruments ready to detect the light so that scientists can analyze it. Webb's focal plane actually is rather complicated to look at, but I've drawn your attention here to 2 of the 5 main instruments. The first of which is called NIRCam. NIRCam is the near-infrared camera. And the second is MIRI, that's the mid-infrared instrument. And you can see that they have different views of the focal plane, and those views don't overlap. So if you want to combine NIRCam and MIRI data, you're going to have to capture part of the sky with NIRCam first, and then slightly adjust the pointing of the telescope so that MIRI's focal plane overlaps, and then capture the MIRI data and combine it. This can be quite an arduous process, and it can take a long time to take Webb observations and build up a complete picture of what it is that you want to see. Moreover, if you want to make a mosaic of the sky, well, you can see that NIRCam has these 2 different regions and they don't touch each other. There's a gap between them. So in order to create seamless mosaics, NIRCam has to tile up the sky, and that also takes a long time. But that is of great astronomical value, and the images that are produced as a result are truly spectacular. There's another aspect to these Webb images that I think it's valuable to understand. Remember, Webb is capturing infrared light, so we don't see this light with our eyes at all, and yet the images that we see in the book are in full glorious color, and yet none of the colors that are represented in the image are the same as the colors that were captured by Webb. They have to be assigned to different channels. Let's take a look at how Webb images are made. So for any image, there will be a number of channels, and for a colorful image, that will be 2 or more, preferably 3 or more, to produce a very colorful image. Each channel is captured through a filter. Now on the left-hand side here is a single channel image captured through a filter called F277W. And the same image is shown on the right, but the image on the right has been stretched and this stretching process allows more shades to be represented. So this is important in order to bring out the details, particularly in darker regions of the image. If we go forward though, we can see that we require more than one channel to make a full color image. So in this image that I produced, I took 4 color channels from NearCam. The first is F150W, which I shaded blue. The second is F187N, which I shaded cyan. The third is F277W, we just saw, and I shaded that one orange. And finally, F444W, which I shaded red. And when those images are aligned and merged together, we get a 4-channel color composite. And if I just take one panel from that, you can see the details that are represented there and the subtle shades of color that appear. In particular, differences in the color between the gas, the nebula, and the stars around it. But the crucial thing to keep in mind is that those 4 channels that you see on the left-hand side there, they are all infrared wavelengths that would otherwise be invisible to the eye. So there's an element of artistry in how these images are created and presented. In fact, I would say this astro image processing is one of the best intersections between science and art. And you can download Webb data and try doing this yourself if you want to. So throughout Unknown Universe, every single image you see is going to be made up of different color channels, and I've made sure that the different channels and the colors that they were assigned are shown for each image so you can see how they were put together. So with that in mind, let's go ahead and look at 5 images from this book.
Yeah. But this feels like, so if you look at the way this has gone down and been reacted to by so many different people, it feels hugely significant, is it?
Yeah, this is a red letter day for astronomers. Well, it's like an infrared letter day for astronomers because this is the most powerful infrared observatory ever to come online, the most powerful space telescope. Seeing these images, of course, if you don't know much about them, you might think, oh, it looks like another image of space. But astronomers everywhere are probably shaking at the sight of these images. They're incredible.
Many people, I've been looking up Cosmic Cliff today. Is that what
Cosmic
this is?
Cliff, yeah. I think they saved this one till last, and I can see why. It's just
isn't it?
astonishing.
The first image is one of the most famous images that Webb has produced, and it was one of the first, released in July of 2022. So among that first image release, we had galaxies, we had dying stars, and we had this incredible vista of what is known as the cosmic cliffs in the Carina Nebula. It's just a gorgeous image, not only because of the fine detail, which really exceeds what was possible before, but also the processing and the palette that has been chosen here. And if we zoom in, we can see just how beautiful those details are. We can actually also see stars that are embedded inside the gas and dust in the Carina Nebula and stars in the distance behind shining through the gas and dust. This is one of the hallmarks of infrared astronomy, and it's really one of the reasons why Webb was built in the first place. As I mentioned before, Webb has 2 instruments, NearCam and MIRI, and NearCam, as its name suggests, sees in the near-infrared and MIRI in the mid-infrared. And we can compare the 2 datasets from these 2 cameras for the cosmic cliffs, and if we switch from the NearCam data to the MIRI data, we get a totally different impression of the same part of the sky. So MIRI complements NearCam for some kinds of study. Overall, this was just an extraordinary image, and I think it was a perfect thing to release to capture the world's attention back in July of 2022. And it really is no surprise to me that this image ended up becoming so many desktop and phone wallpapers so quickly. I think I still go back to it on my own phone from time to time, just so I can absorb it and take it in. Now, my second favorite image is really quite different. This time, instead of looking at a distant object in the Milky Way, we're looking at something much closer to home. It's a planet, and this is the planet Uranus, the 7th planet from the Sun and the coldest planet in the solar system. This extraordinary portrait brings out so much detail in the Uranian system. We can see numerous moons, and Uranus has 27 moons, some of which are rather small. And we also see the rings as well. And Uranus is not known for its rings because, unlike Saturn's rings, they don't shine so brightly. But in this Webb portrait, the rings are very clearly seen. Now, that's because Webb's instruments are so sensitive, and we can admire that sensitivity by zooming out and looking at the background to this image. Now, if I take an image of a planet with my own telescope, I have to use short exposures, and as a result, the planet will appear surrounded by a dark void. We won't see background stars, and certainly not fainter or more distant objects. But with Webb, the situation couldn't be more different. If we explore the background, we see not just stars, but galaxies. So we're looking into a cosmic expanse beyond Uranus. And the sense of depth in this scene is absolutely incredible to me. There are galaxies galore. That's the only way I can describe it. And we can see small blob-like elliptical galaxies, and we can also see spiral-type galaxies with sweeping spiral arms. All of this framed behind the seventh planet. There is one more reason why I absolutely love this portrait of Uranus, and that's because Uranus was discovered by an English astronomer called William Herschel. But Herschel is also very well known in physics as the man who discovered the infrared part of the spectrum, and it is that part of the spectrum that the James Webb Space Telescope was built to study. So I think this is a very fitting image for a cutting-edge infrared observatory to be capturing. Third among my favourite images is none other than the Tarantula Nebula, the largest nebula complex ever discovered. It actually exists in a satellite galaxy of the Milky Way called the Large Magellanic Cloud. I have seen the Tarantula Nebula myself. I've seen it with my own eyes, and I've seen it with binoculars and telescopes, and it's magnificent. But I tell you what, I have never seen it like this before. This portrait is so dazzling to me. It captures huge tendrils of gas and dust that are being sculpted by the winds of powerful stars. In the center of the nebula, we can see the cluster that's responsible for most of that turbulence, and it's a young cluster of powerful, massive stars that emit powerful stellar winds that cause the gas around them to billow out. Just looking elsewhere, we can also see these structures forming where the gas is more dense and it's resisting the flow of the surrounding material, carving out these hills and mountains and tadpole-like structures. Oh, it's just an amazing image, and it looks fantastic in the book as well, edge to edge across the full page spread. So that's one you can admire yourself. I also can't recommend enough downloading the full resolution image and zooming in and having a look at those details. Let's look at image number 4. And this was a late inclusion. So I'm delighted that we were able to put it in the book because it was published only shortly before the book went to print. This is actually an image of a very famous scene in the sky, but what are we looking at here? To get some context, let's zoom out and see which part of the sky we're admiring. From the Euclid Space Observatory, with its wide field of view, you may recognize this. It's the Horsehead Nebula, a very well-known object in Orion. And then if we zoom in with Hubble just on the horse's head itself, and zoom in further again, we can see that Webb is showing us just the top of the horse head. And it looks like the top of a fluffy cloud. It's such a dreamlike image. I'm obsessed with it. The color is also very well chosen and very unusual for a view like this. What I love in particular about this image and the way that Webb differentiates itself as an infrared observatory is that the horsehead is a cloud of dust and gas, and normally that would absorb light. But infrared wavelengths are capable of traveling through that gas and dust unimpeded. So with a powerful infrared observatory like Webb, if we zoom in on the gas and dust, we can actually see galaxies behind it. It's like doing an X-ray on the Horsehead Nebula and looking straight through it, but we're not looking at X-rays here. We're looking at the infrared. Looking above the top of that wispy cloud-like structure and sort of over the top of the horse's head, we can get a clearer view of many galaxies beyond. And there really are a lot of galaxies in this image. That's one of the characteristic things about Webb images that makes them so striking, is that the telescope is just so sensitive that almost every image is full of background galaxies, because there are galaxies in every single part of the sky. And I love that because it adds a cosmic dimension, a truly massive intergalactic dimension to all of these familiar sights, and basically allows us to see them with new eyes, as if we were suddenly much more aware of everything that was out there. And even though these are background galaxies, Webb achieves such fine resolution in the infrared that if we zoom in on them, we can often see details like the speckling or mottling here in this spiral galaxy, revealing the presence of powerful star clusters within the galaxy's spiral arms. Just a beautiful image, and one that I think is going to stand the test of time and remain one of my all-time favorites from Webb. So finally, sticking with the constellation Orion, I want to show you another famous object, but again, this time in, figuratively and literally, a new light. And this is an image that's special to me. Here we are looking into the heart of the Orion Nebula. And just to the left of center is a famous star cluster known as the Trapezium cluster. This is readily seen with just a pair of binoculars and looks really good in a telescope. So this is something you can go and find yourself in the winter sky. But this image is just also full of interactions between stars and the gas and dust that surrounds them. So we see how stellar winds shape and sculpt the gas in the nebula, and sometimes something catastrophic happens. So about 2,000 years ago, a star, or perhaps two colliding stars, exploded, and this produced a shockwave that has traveled through the nebula, heating up the gas, creating what are known as explosion fingers. The green and white fingertips reveal the presence of gaseous iron. So we're able to actually study the composition of this shock front as it travels through the nebula, thanks to Webb's sensitivity. Now, it's special for me that this image could be included because it was taken by somebody that I admire as part of his own scientific work, and that is Dr. Mark McCaughrean, an interdisciplinary scientist on the JWST Science Working Group, and once upon a time, my mentor during my undergraduate university years. Mark not only gave me permission to include some of his own fantastic Webb images, but he also wrote a foreword for Unknown Universe from his perspective as one of the scientists that worked on the telescope. So if you would like to read Mark's foreword and explore over 120 astonishing images, celebrate the first years of the James Webb Space Telescope mission with your own copy of Unknown Universe, which is available wherever you buy your books. Oh, and if you want to know more about how the images are made, look for the links to the Collins Astronomy blog.